In this video here, we're going to take a look at volumes of revolution about the y-axis. Now, as mentioned in the previous video, just ensure that you're confident with all integration techniques from A-Level Maths. So for example here, integration by parts, integration by substitution, integrating trigonometric functions, so on and so on. Obviously, integration, as we mentioned in the previous video, is fundamental here to volumes of revolution. And then finally here, let's just quickly recap the appropriate formula then for volumes of revolution about the y-axis. So for the volume of revolution form when y equals f of x is rotated 2 pi radians about the y-axis between y equals a and y equals b, this is given by the following result here. So v, the volume, is equal to pi times by the integral then from a to b of x squared with respect to y, so dy here. Now again, this result shouldn't be new to you, right? We've already introduced this as part of the first year material here, 2 volumes of revolution. Okay. So there we have it. That gives us our introduction here. We don't need any new theory or anything like that. We are just recapping the first year material here then for volumes of revolution. So let's get started then, and let's take a look at one example here for volumes of revolution about the y-axis. So let's get started then with this example here for volumes of revolution about the y-axis. So what do we have for this question here? Well, straight away we can see this diagram here, and this diagram then shows the curve with this given equation of y equals 2 ln of x minus 1. We have the finite region R here, which is shown shaded in the diagram, and this is bounded by the curve, the x-axis, the y-axis, and the line y equals 4. The region R is rotated through 2 pi radians about the y-axis here, and it says then using calculus show that the exact volume of R can be given as this here. So where do we begin here? Well, given that we're rotating through 2 pi radians about the y-axis here, to find this volume then, which we're given here, we need the following result then. So v here is equal to pi times by the integral then, which in this case would go from 0 to 4 here. So from 0 to 4 here. And because we're going about the y-axis, we integrate x squared then with respect to y. So x squared here, dy. Now, given that this equation here is in terms of y, clearly we just need to rearrange this here and make x the subject. So we have y equals 2 ln of x minus 1. So if we rearrange this here, then what do we get? Well, I get ln of x minus 1. I'll write this here. So ln of x minus 1 is equal then to y over 2. So y over 2 here. We then get x minus 1 is equal to e, the power of y over 2. And then finally here, we just want x as the subject, just add 1 to both sides. And we get that x is equal here to e, the power of y over 2 plus 1. Okay. So in that case then, for the volume here, v is equal to pi times by the integral here then from 0 to 4. Obviously the limits won't change. So from 0 to 4 then of x squared. Well, x is equal to e to the y over 2 plus 1. So obviously we just need to square that then. So we have e to the y over 2 plus 1. And we square this here, right? And we're integrating then with respect to y. So dy here. So when we square this here, what do we get then? Well, let me just write this underneath my diagram. So e y over 2 plus 1 times by itself again. Obviously just expanding double brackets here. I'll write out in full just so you can see what we have. So if we expand this, then what do we get here? So e to the y over 2 times by e to the y over 2. That would just give me e to the y then. So e to the y there. I then have e to the y over 2 times by 1. And again, we do it here. So 1 times e to the y over 2. So what I get then is 2 lots of e to the y over 2. We get 2e to the y over 2. And then finally here, 1 times by 1. So we get plus 1 to finish with there. So we're integrating here then. b is equal to pi times by the integral then from 0 to 4. So we have this full expression here then. So e to the y plus 2e plus 2e to the y over 2 plus 1, like so. And again, this is with respect to y here, so dy. Okay, so just integrating this here, nice and straightforward. What do we get then? I'll do it underneath really, I've got enough room. So v here is equal to pi. So what do we get then? Well, e to the y, we integrate this here with respect to y, that would just simply give me e to the y. E to the y there. We then have 2e to the y over 2. Now we need to divide this here by a half. So dividing by a half is the same as timesing through by 2. So 2 times by 2 gives me 4. So I get 4e, so plus 4e to the y over 2. And then finally here, this plus 1, that would just give me plus y there. Okay. And again, don't forget the limits here from 0 to 4. So from 0 to 4 there, like so. And all we need to do now is substitute our limits in here. Obviously, don't forget we start with the upper limit and we subtract the lower limit here. So what do we get then? Well, I get pi times by. So starting with the upper limit then, well, I get e to the 4. I get e to the 4. We then have 4e to the power of 4 over 2. So 4 over 2 is 2, so I get 4e squared. So plus 4e squared. And then we have plus y here, so that would be plus 4. So plus 4 there, like so. And now we subtract here the lower limit. So for the lower limit then, what do we get here? Well, e to the 0, that would be 1. I'll write it in full here. So e to the 0. We then have 4e to the power of 0 again here. 0 over 2 is again just 0. So 4e to the 0. And then finally plus 0 here. So plus 0, like so. So we simplify this here then. I get pi times by. So I've got e to the 4 plus 4e squared plus 4. Can't do anything with that bracket. With this bracket here, what do we get then? Well, e to the 0 is 1. We then have 4 lots of 1. So 1 plus 4 is 5. So I've got e to the 4 plus 4e squared. We have plus 4 there. And then minus 5. And then to finish with here, find that v is equal to pi times by. We get e to the 4. Can't do anything with that. Plus 4e squared. So 4e squared there. And then finally here, 4 minus 5 gives us the minus 1 that we need here. So we get minus 1. Okay. And notice here then, we've got the exact volume that we required. And there we have it. So that gives us the solution there to this example. And that brings us to the end then of this video here on volumes of revolution about the y-axis.